For finding the end behavior of a polynomial when x approaches either positive or negative infinity, its limit or end behavior only matches the end behavior of its highest degree term. So if the polynomial is c sub o plus c sub 1x plus c sub nx to the power of n, where n here is the highest degree term, then the limit of that polynomial as x approaches infinity is just equal to the limit of this highest degree term c sub nx to the power of n as x approaches positive infinity. And the same goes when x approaches negative infinity. You just look for the highest term, highest degree term. So this is just equal to the limit of c sub nx to the power of n as x approaches negative infinity. And we evaluate or find this limit by using what we have learned in the previous discussion. So for example, we are to find the limit of 7x to the power of 5 minus 4x cubed plus 2x plus 9 as x approaches negative infinity. So because this is the highest degree term here, then this limit is just equal to the limit of 7x to the power of 5 as x approaches negative infinity. And from what we have learned, if it's odd for an polynomial x to the power of n, and this is odd here, then the curve would look like this. And so when x approaches negative infinity, what happens to the function? When x approaches negative infinity, then y also goes to negative infinity. So our answer, this is equal to negative infinity. If x was approaching positive infinity, then our limit here would be positive infinity because it is also increasing. Another example, we are to find the limit of negative 4x to the power of 8 plus 17x cubed minus 5x plus 1 as x approaches negative infinity. And so the highest degree term is this term right here. So this limit is just equal to the limit of negative 4x to the power of 8 as x approaches negative infinity. And again, from what we have learned, if it's even and it's negative here, then our curve would be like this. It's facing downward. And so when x approaches negative infinity, y also approaches negative infinity. So our answer for this number is also negative infinity. If this was x to the power of 8, positive 4x to the power of 8, the curve would have been facing upward. And so when x approaches negative infinity, our answer would have been positive infinity because y is going upward. Okay, so that's how we find the limits of polynomials at infinity. So it's different when we are finding the limits of rational functions at infinity. This time we're given fractions. So to determine the end behavior of a rational function is to divide each term in the numerator and denominator by the highest power of x that occurs in the denominator, after which the limiting behavior can be determined using the results established. That occurs in either the numerator or denominator. So this is either in the numerator or denominator. So for example, we are to find the limit of 3x plus 5 over 6x minus 8 as x approaches infinity. So we're just going to focus on positive infinity right here. So let us just, okay, automatically positive infinity. So this is equal to, because we are not yet evaluating the limit, so let's still write limit. And then the highest degree of x is 1. So we're going to divide each term here by x. So that would be 3 plus 5 over x divided by 6 minus 8 over x as x approaches infinity. And so if you recall, when we introduce limits at infinity, the limit of 1 over x as x approaches infinity is equal to 0. So when we evaluate the limit here, and this is a constant, so the limit of a constant is just a constant itself, because this can be written as the limit of 3 plus 5 over x as x approaches infinity divided by the limit of 6 minus 8 over x as x approaches infinity. And then we can evaluate the limits individually. So the limit of a constant as x approaches to whatever value there is still the constant itself, 3, plus the limit of 5 over x as x approaches infinity, because it's a constant right here, so it would just be the same as this one, because we can just put the 5 here, the constant, before the limit. And so the limit of 5 over x as x approaches infinity is just equal to 0. In the denominator, the limit of 6 as x approaches infinity is still 6, and plus that is still 0. So our answer is 3 over 6, or that is equal to 1/2. So that is the limit of the rational function as x approaches infinity. Okay, we have the limit of this is 4x squared minus x over 2x cubed minus 5 as x approaches infinity. So the highest degree is x cubed, so we're going to divide each term here by x cubed rather. So this is equal to the limit of 4 over x, again because this is 4x squared, so divided by x cubed, we get 4 over x minus 1 over x squared divided by 2 minus 5 over x cubed as x approaches infinity. And so with the variables in the denominator, it will automatically be, the limit would automatically be 0. So 0 minus 0 over 2 minus 0, so the answer is just 0. Third one, we have the limit of 5x cubed minus 2x squared plus 1 over 1 minus 3x. And the highest degree term is x cubed, so we're going to write that as the limit of 5, because we're dividing each term by x cubed, minus 2 over x plus 1 over x cubed all over 1 over x cubed minus 3 over x squared as x approaches infinity. And so by substituting here, this would still be, the limit would still be 5. And then minus 0 plus 0. Limit is 0, also 0. And this is 0 and 0. So 0 minus 0. So you have a number divided by 0 is undefined. But you don't write your answer as undefined. Remember, if it's undefined, the interpretation right there is that because it's not defined, then you conclude that there is no limit, or the limit does not exist. So if you get an answer that is undefined, remember to always conclude that the limit does not exist. So actually, even if you don't solve it like this, if we're just looking at the exponents of the polynomial in the numerator and denominator, we can already predict what the limit is. So for example, for number 1, because the exponent or the degree of the polynomial in the numerator and denominator are equal, it means to say that the limit, it only applies when x approaches infinity. So the limit is just actually these coefficients right here of the highest degree term. So 3 over 6 or 1/2. Should we have written limit of, let's say for example, 2x cubed minus 4x squared plus 5x minus 1 all over, let's say for example, 2x cubed plus 1 as x approaches infinity, because the degree of the polynomial in the numerator and denominator are equal, it's just 3, then we are simply going to look at their coefficients. And so the coefficient of x cubed in the numerator is 2, and the coefficient of x cubed in the denominator is also 2. And so our limit is 1. So all we need to do is to look at the coefficients. If equal, if the order or the degree of the polynomial and the numerator are equal. However, in this case right here, number 2, if the degree of the polynomial in the denominator is greater than that of the degree of the polynomial in the numerator, this is 3 here in the denominator and it's just 2 here in the numerator, automatically the limit is 0. So if you have another example like the limit of x plus 2 over x squared minus 4, for example, let's say x squared plus 4, as x approaches positive infinity, because the degree of the polynomial here is greater than that of the numerator, we can automatically just say that the limit is 0. And third, if the degree of the polynomial in the numerator is greater than that of the denominator, then automatically your answer is that there is no limit or the limit does not exist. So like for example, we evaluate the limit of 4x to the power of 4 minus 1 divided by, let's say, x plus 1 as x approaches infinity. So because the degree of the polynomial in the numerator is greater than that of the polynomial in the denominator, even if we increase this exponent, let's say it's x squared. So the degree of the polynomial in the numerator is still greater than that of the polynomial in the denominator. So our answer here is the limit does not exist.